Okay, question 4. So we've got a mass on a rough plane, angle of 25 degrees to the horizontal. Mu is mu, hold it at rest, let it go, and slides down. Okay, so we need our force diagram. Inclined plane at 25 degrees. I got a object of mass 60 on that. Mu for part A is 0.3 and it's sliding down the plane. Okay, so it's going down the plane, acceleration. So the forces on this object are its weight, 60 g. There's a normal reaction that's perpendicular to the surface, R, and because it's moving downwards and this plane is rough, there's a frictional force acting in the opposite direction, which is moving of F upwards, and those are the forces acting. Now we're going to apply Newton's second law parallel to the plane in the direction of the acceleration and perpendicular to the plane. So F is parallel to the plane, R is perpendicular, but my 60g isn't in either of those directions. So I need to get the two components of the 60g in the direction parallel and perpendicular. So the 60g will have a component in that direction, a component in that direction. Now if that's 25, that angle there is 25, so this side is the adjacent, which tells me this is the cos component. So that's 60g cos 25 in that direction, 60g sine 25 in that direction. Now I apply Newton's second law parallel to the plane. So there's the acceleration going down, so it's 60 g sine 25 minus F equals mass times acceleration, 60a, and perpendicular to the plane I got R is equal to 60g cos 25, and because I have motion, for motion, the law of friction tells me that F is equal to mu R and mu is 0.3. So there's my three equations, and now it's just about number crunching. So first of all I'd calculate R because I got everything there. Okay, so R is 60 times 9.8 times the cos of 25. That gives me 532.9. And then if I sub that into the equation below to get F is equal to 0.3 times R. So leave that value on the calculator and just simply multiply by 0.3. And that gives me 159.9 if I go to one decimal places newtons. Okay, now that was the first part that was asked. So part 1, F is 159.9. Then part 2, I want the acceleration. Well, I'm now going back up to the first equation. So 60 times 9.8 times the sine of 25. Take away the frictional force, which is 159.9, and that equals 60A. And then to find A, I calculate the left hand side and divide by 60. So that's 88.59, which is 60, is equal to 60A. So A is 88.60 divided by 60. And that gives me 1.476, which is 1.48 meters per second squared. Okay, that's part A. Then to do part B. So it's given that when the object is released, it remains stationary. Calculate the least value of mu. Now then, if this remains stationary, that means that we have the condition that f less than or equal to mu r. Okay, and I'll bring it back to A, sorry. Okay, that's the setup in the first diagram. What's happening now for stationary? I don't have an A there, so I need my forces on that diagram. So drawing out part B again. That's 25. I've got my 60 kilogram mass there. 60 G R. When it's released, it remains stationary. Okay, so basically there's no acceleration there. There will be a tendency for it to move down, so we'd expect the friction upwards. So two components of the 60G, just following it from the first part. 60G cos 25, 60G sin 25. Now then, if it's stationary, okay, the condition here that it's stationary is that the 60G sin 25 isn't bigger than that frictional force there. Unless that 60G sin 25 is greater than that F, nothing's going to happen. Okay, so the least possible value is going to occur when it is at the point of moving. Okay, so the least possible value is going to be when this weight component 60G sin 25 is equal to F. Okay, now then, F by law of friction is less than or equal to mu r. Okay, so if I get the r component, which I've got from the first part, okay, r is equal to 60G cos 25. I've calculated that once. 60 times 1.8 cos 25. It's 532.9. Okay, so there's the frictional force, there's the reaction, and what I now know is that 60G, right, F is less than or equal to mu r, so 60G sin 25 is less than or equal to mu times 532.9. So 60G sin 25 over 532.9 is less than or equal to mu. So just calculating that out. That gives me 0.466 less than or equal to mu. So mu is always greater or equal to that, so the least value is when it is equal to that. So the least value is mu is equal to 0.466. Okay, so that particle there doesn't move until that force down the plane, which is the weight component, is greater than our frictional force.